Okay, so we're going to look at some chemical equations this time. The warm-up's asking us to look at a word equation and then decide whether or not certain statements are true or false. It's the reaction between magnesium and hydrochloric acid as two reactants and producing magnesium chloride and hydrogen. So statement number one, hydrogen is a product in the reaction. I just said that is true. It is one of the products on the right-hand side of the equation. Question 2, the equation shows a reaction between chlorine and hydrogen. It specifies chlorine. Chlorine's not actually in the equation at all, so that's false. And hydrochloric acid is a reactant, so on the left-hand side. Likewise, hydrochloric acid and magnesium are also on the left-hand side, so the fourth one is true as well. Question 1 then asks us properly to construct a word equation between two reactants, sodium and chlorine. So they're the two reactants. They go on the left-hand side of the equation. So sodium reacting with chlorine. We don't have to specify necessarily that we've got a gas this time. We'll do that probably more correctly when we do symbol equations later. But sodium and chlorine are the two reactants, and they're forming sodium chloride only. So there's only one product in this reaction, and it is sodium chloride. And question 1.2 is then going to ask us to transfer that word equation into full symbols. Now the question has actually given you the symbols quite helpfully. So we're told it's Na, we're told it's Cl2, and we're told the product was NaCl already. So all we're going to have to do really is construct that equation by eliminating the second equation, because that's got Na2 in it, therefore we can get rid of that one as being as a viable answer. Likewise, the third one also has Na2 in it, and the top one doesn't have the presence of Cl2. Therefore, we've only got one left. This one is the correctly balanced equation. The answer is the fourth one. Question 2 then does ask us to try and balance up an equation properly this time, and what we have to do is essentially try to balance this up from scratch. And as with all balancing equations, there's often no correct place to start, but it's often helpful, as we've seen on numerous cases, that whenever you have a 3 in an equation, as we do here, it's often helpful to put a 2 in there and try to balance it up from there. That then gives us 6 hydrogens on the left-hand side of the equation, but only 2 hydrogens in the presence of water on the right-hand side, so we have to multiply that by 3. On the left-hand side, we'd introduce 2 ammonias, which has 2 nitrogens in it, so we have to double up the number of nitrogen monoxides on the right-hand side, and then we need to just complete the oxygens. The right-hand side of the equation, there are 3 oxygens in 3 lots of water. There are then 2 lots of oxygen in 2 lots of nitrogen monoxide, which means that we've in total got 5 oxygens present on the left-hand side, and also we'll have to have that present on both sides. So 5 oxygens. We have an O2 molecule, and in order to make 2 become 5 oxygens, we have to multiply that up by 2.5. Okay, so we can leave that as a half. Now, in an ideal world, what we'd like to do is try and get rid of the halves, so we'd have 4 and 5 on this side of the equation, so we can get rid of the half. And likewise, we'd like to have 4 and 6 on this side of the equation, just to have nicer looking numbers, and rather than the half, although it is fine to leave the half if you want to. So, final question on this page. The reaction below shows the final stage of the manufacture of nitric acid. The equation is not balanced correctly. How do we know? Well, we can look at the nitrogens. First of all, we've got 2 nitrogens, we've got 2 nitrogens, we've got 2 hydrogens, we've got 2 hydrogens. The problem is the oxygen. On the right-hand side, we've got 6 oxygens within this compound, but on the left-hand side, if you add them all together, we've got 7. And so 7 does not equal 6, and so it's an incorrectly balanced equation.